For a long time, we've basically been flying blind when it comes to our most critical equipment. I mean, think about it. A single failure can cause a shutdown that costs millions. And what have we been doing? We take a snapshot, an inspection, and then just hope for the best. But what if we didn't have to hope? What if we could see everything all the time? Well, that's the big shift we're seeing now, moving away from those occasional checks to a continuous 24/7 model that can spot trouble way before it turns into a disaster.
Yeah, that old way was just a total gamble, wasn't it? You'd do your inspection, you'd cross your fingers, and you'd just hope nothing bad happened in those weeks or months until the next one. But that gap, that's where all the danger is hiding. The new way, well, it gets rid of that gamble entirely. It's all about catching weird behavior the second it starts. This gives us a huge head start to stop leaks, ruptures, or those shutdowns nobody wants. Now, it's really important to get this straight. This is not about replacing human experts. Not at all. It's about a whole new philosophy, summed up perfectly by this phrase: screening all the time, verifying at the right time. So you can think of it like this. You've got this constant automated screening system that's always on, always listening in the background. It flags potential problems, which then lets our inspectors go in with total focus, with precision, exactly when and where they're needed most.
Okay, so how do we actually do this? How do we listen to our equipment around the clock? Well, it really boils down to three main types of technology. These are the core tools making this whole revolution possible. So let's dive in and break them down. All right, first up, we've got something called acoustic emission, or just AE for short. And honestly, the best way to think about this is that we're literally listening to damage. Anytime a material starts to crack, or even when there's friction, it lets off this tiny, super high-frequency burst of energy. AE sensors are so sensitive they can actually hear those signals, and that tells us that some kind of damage is actively happening right now. And that's the absolute key here. AE only hears active damage. It's not going to tell you about some old stable flaw that's been there for years. Nope. This is all about catching problems as they're happening, as they're growing. Now, this does mean you need an expert to translate what all those sounds mean, but when it comes to detecting threats in real time, its power is just unmatched. Okay, next up we have guided waves. You'll often hear this called LRUT, so picture this. You send a pulse of sound down a really long pipe, all from a single spot. That pulse then travels, sometimes for hundreds of feet, and as it goes, it's listening for any echoes coming back. Those echoes tell you if there are changes in the pipe's thickness. You know, the kind of changes you get from corrosion or erosion. So where is this technology a real hero? Well, it shines in all those places that are just impossible to get to. We're talking about those complex pipe racks way up in the air, or lines that have to cross under a road or a river, or even pipes that are hidden under thick layers of insulation. Guided waves let you screen massive sections of these tricky assets without having to, get up close and personal with every single foot of pipe. And our third technology, wow, this one is a total game changer. It's called distributed fiber-optic sensing, or DFOS. So get this. Imagine running a single fiber-optic cable. We're talking as thin as a human hair, along a whole pipeline. And instantly, that one cable turns into thousands of tiny sensors. Each one is listening for the sound of a leak, feeling for any changes in temperature, and even sensing physical strain on the pipe. You can see why DFOS is quickly becoming the go-to solution for monitoring long pipelines, right? I mean, if a tiny pinhole leak starts up miles from anywhere, DFOS can pinpoint its exact location within seconds. That gives operators an incredible level of awareness, a critical head start to get things shut down, and stop a small problem from turning into a massive disaster. Okay, so collecting all this data from thousands of sensors, that's one piece of the puzzle. But making sense of all that information, that's a whole other challenge. And, you guessed it, that's where the big buzzword comes into play: AI. So let's talk about what it's really doing here. You know, a lot of folks hear AI and they immediately picture some kind of magic inspector, right? This all-knowing superbrain that can just glance at the data and say, yep, that part's good, or nope, that one's bad. But is that really what's going on? The short answer, a hard no. AI is not here to replace our engineers or to rewrite safety codes. Its real power, its real genius, lies in a totally different kind of intelligence. So here's what AI is actually brilliant at: pattern recognition. It's an absolute master at sifting through mountains and mountains of data to find that one tiny signal that's just a little bit off, the anomaly. Think of it as a filter, not a judge. It spends its time learning what normal looks and sounds and feels like for your equipment. Then, its job is simply to flag anything that deviates from that normal, cut down on the false alarms, and help our human experts focus their precious time on the things that actually matter. Okay, this all sounds fantastic in theory, right? But the big question is, how do you actually get started with this in your plant? And the key, really, is to think small. You do not need to overhaul your entire facility overnight. You just start with one focused pilot project.
A 30-day pilot, that's the perfect way to just test the waters. So, step 1, just select one single high-risk asset. Step 2, define the specific threat you're most concerned about for that asset. Third, you choose the right tech for that specific job. Number 4, and this one's crucial, you have to decide exactly what's going to trigger an alarm. Fifth, you need a clear, actionable plan for what to do when that alarm goes off. And finally, number 6, you review everything and you refine the process. It's a simple, repeatable way to build confidence in the system.
So, if you remember one thing from all this, what's the big takeaway? It's really a simple formula for the future of equipment integrity. You take your physical asset, the metal, you add 24/7 monitoring, and that equals real actionable evidence. It's really all about replacing guesswork with certainty that's backed by data. So, I'll leave you with this question to think about. In the time between your scheduled inspections, in all those weeks and months of silence, what surprises might be lurking? What quiet changes are happening inside your equipment that you just can't see? The thing is, with continuous monitoring, you really don't have to wonder anymore.